Okay, thanks a lot for introducing me, Dr. Professor Kim Jong-ha. And thanks everybody for being here today. I'm Youngjun Kim, an assistant professor at the Department of Agriculture and Resource Economics at Kangwon National University. And I very much appreciate this chance to talk about my research. And okay, the title of today's presentation is called Effects of Crop Insurance on Farm Disinvestment and Exit Decisions. This paper was published in the European Review of Agricultural Economics back in 2020, and it is a joint work with Dr. Jisang Yu and Dr. Dustin Pendel at Kansas State University. And I know some of you major in agricultural economics. I hope this will be a good chance to learn how to measure, evaluate agricultural policy. But I know some of you do not major in agricultural economics, so I hope this paper and this presentation will be a good chance to learn agricultural policy and risk management tools. Okay, let's get started. The fourth U.S. National Climate Assessment, called NCA4, surveyed recent scientific literature on climate change. Among the findings are, first, global annually average temperature has increased by about 1.8 degrees Fahrenheit, 1.0 degrees Celsius, from 1901 to 2016, and especially by 1.2 Fahrenheit, 0.065 degrees Celsius for the period 1986 to 2015. And this period is the warmest in the history of modern civilization. Second, current concentrations of atmospheric greenhouse gases commit to the world further warming. It is expected that the global temperature will getting increased regardless of these future greenhouse gases. Third, actual precipitation has increased across most of the northern and eastern United States and decreased across much of the southern and western United States. In addition to this geographical distribution, a change in seasonal distribution in precipitation are also projected. Finally, food and forage production will decline in the U.S. regions experiencing increased frequency and duration of drought. Shifting precipitation patterns will intensify wildfires that reduce forage and also accelerate the depletion of water for irrigation, and will increase the number of incidents of livestock disease and crop pests. So, as you all expected, agricultural producers face various risks in their revenue and quantity. So, crop insurance is developed in many countries, and now it is expanding in the US and in the Europe and also in many developing countries to protect agricultural producers' revenue and their quantity. And many governments in many developing countries and US, even in Korea, offers a huge amount of subsidies on crop insurance, because crop insurance is a really important, one of important risk management tools. And there are several risk management tools, including crop insurance, price support program, and revenue support program. but crop insurance is one of the most important risk management tool in many countries. So crop insurance is a government program and heavily subsidized, but little is known about the impact of crop insurance on farm survival and farm disinvestment. So in this paper, we answered the following research question. Does subsidized crop insurance really affect farm disinvestment and exit decisions of farms? There has been several studies that explored determinants of farm survival, and these include farm characteristics, marketing strategies, cooperative extension, and government payments. But little is known about the impact of crop insurance on farm survival. So we contribute to the literature on farm survival and crop insurance by analyzing the impact of crop insurance on farm survival. A prediction from real option theory regarding the impact of crop insurance on farm disinvestment is ambiguous. According to the real option theory developed by Dixit 1989, a reduction in the variability of revenues leads to higher threshold of revenues for farm disinvestment and exit. On the other hand, an increase in the expected value of revenues leads to lower threshold of revenues for farm disinvestment and exit. In our context, crop insurance context, subsidized crop insurance may reduce the volatility of revenues, but at the same time, increase the expected value of revenues. So, crop insurance may increase or decrease exit threshold of farms depending on the parameters. So, to evaluate the impact of crop insurance on farm survival, an empirical assessment is required. Okay, contributions. This study mitigates endogeneity issues of purchasing crop insurance. So what is endogeneity? So purchasing crop insurance is endogenously determined. In other words, the impact of crop insurance on farm survival could be confounded by various factors. So without developed identification strategy, this could over or underestimate the impact of crop insurance. So using a developed identification strategy, kind of cutting-edge identification strategy in agriculture economics, we mitigate endogeneity issues. By doing so, we provide empirical evidence on negative impacts of crop insurance on the likelihood of farm disinvestment and exit decisions. Okay, data. We use Kansas Farm Management Association data called KFMA data, which provides farm-level panel data set. There are a limited number of farm-level data in US, and KFMA is one of them. I fortunately have access to Kansas Farm Management Association because I got my degree at the Kansas State University. And KFMA collects detailed information on accounting and production information from its member, such as farm financial variables, farm characteristics, and farm production variables. The main variable of interest, crop insurance. Crop insurance data exists from 1993. Okay, some people may doubt whether the KFMA, some farms in KFMA data could be representative for US farms. So here I provide the number of farms in KFMA dataset and US Census Agriculture by group. So we can see two data, and we can also find that these two data shows similar patterns by groups: farm by value of sales and farms by type. Except corn, these two data shows similar patterns. So we believe that our paper could provide important economic insights on the impact of crop insurance on farm survival. Okay, these figures shows the number of insured and uninsured farms from 1993 to 2016. This white area shows the number of insured farms, and this blue area shows the number of uninsured farms. As you all see, the number of farms, the total number of farms gradually decreased over time. And also, the number of insured farms and uninsured farms also decreased over time. But here we can easily find that the proportion of insured farms over the total number of farms gradually increased over time. This table shows summary statistics for a selected variables. These variables include total crop acres, operator age, crop labor ratio, years operated, machinery and equipment value, value of farm production, non-farm income, total farm capital, debt to asset ratio, owned land over total land. And the key variable of interest, the number of insured years within the last 5 years, has increased from 3.3 in 1998 to 4.5 in 2016. The definition of farm exit is crucial in the literature on farm survival. This table shows how we define farm exit or farm survival in our paper. Producers who participated in the KFMA data may not renew their annual membership for unknown reasons, even though they continue to operate their farming. We find that the average length of consecutive missing years was about 2.5 years. It means that if a farm do not appear in the KFMA data set for more than 3 years, it is likely that these farms have actually exited the business rather than just temporarily left the business. So in this paper, we define farm exit as not participating in the KFMA dataset for more than 3 years. Okay, here let's see farm number 1, 2, 3. Farm 1 was observed in every year, so it is defined as stayer. Farm 2 and 3 were not observed in 1 year and 2 years, respectively. But according to the definition of our farm exit, not participating in the KFMA dataset for more than 3 years, we define these farms as stayer, since these farms, we believe that these farms are likely to reappear in the dataset. Farm 4 and 5 were not observed in the dataset for more than 3 years and for 4 years, respectively. Again, by the definition of farm exit, these farms are defined as state exiter. So we believe that this farm actually exit the business rather than just temporarily left the business. In order to estimate the impact of crop insurance on farm survival, we conduct two complementing empirical analyses. First, estimating effects of crop insurance on farm exits. To do so, we employ duration analyses, which comprise of semi-parametric and non-parametric approach, and propensity score matching. I'm going to explain what propensity score matching is in detail in the following slide. Secondly, we estimate effects of crop insurance on farm disinvestment. To do so, we use OLS, ordinary least square, and propensity score matching method. First, I'm going to explain duration analysis. Cox proportional hazard model is a semi-parametric approach for duration analysis. For a farm that survived until time t, the conditional probability of exiting right after time t is called hazard function, and it is displayed as follows. Function h is hazard function, and h is equal to h naught t times exponential small gamma times t di plus gamma times xi, where h naught t is the baseline hazard function, and di is a variable equal to 1 when a farm I is in the 3-month group and 0 otherwise. xi is a vector of control variables, and these gammas are parameter to be estimated. Farm I is in the 3-month group when farm I had purchased crop insurance consecutively for 5 years. Okay, let me tell you about U.S. crop insurance policy. It's one of the most important crop insurance policy, the Crop Insurance Reform Act of 1994. The Crop Insurance Reform Act of 1994 required farm to participate in the crop insurance program to be eligible for Farm Bill commodity programs such as price support and revenue support and disaster assistance, etc. This mandatory provision was repealed in 1996. Since there is a significant policy change in crop insurance between 1995 and 1996, we use year 1996 as the base year and estimate the survival and disinvestment rate for insured groups and control groups. Propensity score matching. So, in order to analyze the causal impact, the ceteris paribus condition should be met. This is a Latin phrase meaning that holding all others constant. So in our context, we need to hold all other things except crop insurance should be constant between insured groups and uninsured groups. Unfortunately, some farm characteristics variables are associated with crop insurance purchasing decision. For example, some farms with larger acre and some older farms and some farms with larger non-farm income, they are more likely to purchase crop insurance. So ceteris paribus condition is not met. So we need to use identification strategy. Here we use propensity score matching. The principle of propensity score matching is to match uninsured farms to insured farms who share a similar value of propensity score, where the propensity score is the probability of being assigned into a 3-month group given pre-3-month characteristics. We can estimate this propensity score by logit or probit estimation. According to the propensity score theorem, if a potential outcome is independent of 3 months, in our context, crop insurance, conditional on some farm characteristics, the potential outcome is independent of 3 months, conditional on propensity score matching. So by match treated farms and uninsured farms, we can achieve ceteris paribus condition. Following previous researchers that use farm disinvestment as a gradual measure of farm exit, we also conduct the impact of crop insurance on farm disinvestment. If we find statistically significant impacts of crop insurance on farm disinvestment, this result could strengthen our main finding, the impact of crop insurance on farm survival. We use the same approach, propensity score matching method. After using propensity score matching, we estimate equation number 3, where yi is the disinvestment measure and di is a 3-month status, insured farms or uninsured farms, and xi is a vector of control variables. We define farm disinvestment as the change in the amount of value of machinery and equipment value. More specifically, we define farm disinvestment as the average in the ratio of investment over investment in the previous year. Okay, let me move to estimation results part. This table shows propensity score matching estimation results. And here we find that, here the dependent variable is purchasing crop insurance or not, binary variable. We find that non-farm income, total crop acre, total farm capital, debt to asset ratios are correlated with purchasing crop insurance decision. Okay. Let me show you one more picture here. This table shows common support, so these figures shows propensity score distributions between for insured farms and uninsured farms. Propensity score matching requires substantial overlap in propensity scores between two groups. And this shows that significant overlap in propensity score between insured farms and uninsured farms. So this shows that our approach could provide important economic insights on the impact of crop insurance on farm survival. This table shows summary statistics before and after matching. Okay, here let's talk about the before matching sample. We can easily find that before matching, the mean of these variables are statistically different between two groups, 3-month group and control groups. Okay, for example, operator age is quite different between insured farms and uninsured farms. Again, to estimate the causal impact of crop insurance on farm survival, ceteris paribus conditions should be met, we should hold all other things except crop insurance hold. So this is problematic, quite problematic. This could over or underestimate the impact of crop insurance on farm survival. But after matching, we can find that the average of these control variables are not statistically different anymore between insured farms and uninsured farms. So by utilizing propensity score matching, we can achieve ceteris paribus condition. Okay, these two figures shows Kaplan-Meier survival curve before and after matching. These dashed line shows survival probability for insured farms, and these this solid line and this dashed line shows survival probability for uninsured farms before and after matching. And we can see here that the survival probability for insured farms are higher than survival probability of uninsured farms. And after matching, these gaps get slightly wider. So it means that we mitigate this endogeneity issue. Okay, this table shows our main finding, the impact of crop insurance on farm survival. Here, dependent variable is hazard rate, which is opposite to farm survival. In column 1 and 2, we use unmatching sample. In columns 3 to 6, we use matched sample by using propensity score matching method. Here we find that the impact of crop insurance on hazard rate is not significant. But this is because the impact of crop insurance on farm survival is confounded by various factors. But after matching, after achieving ceteris paribus condition, we find that the impact of crop insurance on farm hazard rates the impact of crop insurance on hazard rate is statistically significant across several different specifications. If we convert these numbers, we can interpret that the impact of crop insurance, could reduce farm exit rate by 13 to 15%. This table shows OLS estimation results, impact on farm disinvestment. Here, the dependent variable is disinvestment measure. Again, before matching, the impact of crop insurance on farm disinvestment measure is not statistically significant if we do not include any covariates here. Again, because it is important. These results can be explained that we failed to mitigate endogeneity issue. So we failed to achieve ceteris paribus condition. But after matching, the impact of crop insurance on farm disinvestment measure are quite statistically significant. So we find that crop insurance reduce farm disinvestment rate by about 6%. Again, this result could strengthen our main finding, the impact of crop insurance on farm survival. We conduct an additional analysis, panel fixed effect estimation, where dependent variable is farm exit, and we check whether farm exit is correlated with farm disinvestment. In other words, we want to check whether farm disinvestment is a good proxy for farm exit. Here we find that farm disinvestment is positively associated with farm exit. So we can conclude that farm disinvestment measure is a good proxy of farm exit variable, and this result could strengthen our main analysis, the impact of crop insurance on farm exit. To check whether our findings are quite robust across different specifications, we conduct two more analyses by changing the definition of farm exit. Again, we define farm exit as farms not participating in the KFMA dataset for more than 2 years. We changed this definition slightly. Here, we define farm exit not observed more than 2 years rather than just 3 years. And here, we define farm exit not observed more than 4 years rather than 3 years. As you guys can see here, our results are quite robust with different definition of farm exit. Crop insurance reduce farm exit hazard rate, but with different definition of farm exit. Okay, concluding remarks. We find that crop insurance deters farm disinvestment and farm exit. Again, the problem is in this agriculture economics issue, evaluating agriculture economic issue is that the main variable of interest is endogenously determined. In our context, crop insurance was endogenously determined, so this could over or underestimate the impact of crop insurance on farm survival. But to mitigate this endogeneity issue, we use propensity score matching method. So we can properly evaluate the impact of crop insurance on farm survival. The federal government's offers of subsidized crop insurance actually helps farmers manage various risks in their revenue and quantity resulting from climate change. Future research can estimate heterogeneous impacts of crop insurance on farm survival. For example, whether do farms with poor finance performances benefit more from crop insurance? And we can also apply this approach in many countries, including Korea and African countries, many Asian countries. So we wonder whether crop insurance increase farm survival in many countries. So we can apply this approach in many different countries. Okay, so this is the end of presentation today. Thank you for listening.